Hello, welcome to today's lesson on the distinction between distance and displacement. We'll begin today's lesson by introducing the concept of distance, understanding how it allows us to describe motion as a scalar quantity. Next, we'll introduce the concept of displacement, understanding how it allows us to describe motion as a vector quantity. Finally, we'll compare distance and displacement to clarify the differences. So far, we have explored the differences between scalar and vector quantities. To remind you, scalars have only magnitude, whereas vectors have both magnitude and direction. Building on this foundation, distinguishing between distance and displacement will advance our understanding of motion. Let's get started. Distance is one of the basic concepts used to describe how much ground an object has covered. It's vital to note that distance is always a positive quantity. When you walk from one point to another, the path you take constitutes the distance covered. Distance does not consider the direction of travel. It only measures how much you've moved. For example, if you walk around a square path where each side is 10 meters long, by completing all 4 sides, you've covered a distance of 40 meters. Distance is a scalar quantity, meaning it only has magnitude, size or length. Scalars do not provide any directional information. Knowing the total path length is sufficient to describe the distance. For instance, if someone asks you how far you've walked, answering 40 meters gives them the total distance without needing to describe the direction you took.
Okay, so what's the difference between distance and displacement?
Well, displacement, unlike distance, is a vector quantity. This means it accounts for both the magnitude and the direction of the change in position, from the starting point to the ending point. Returning to the square path example, if you walk from the bottom left corner to the top right corner, covering 2 sides of the square, you walk a distance of 20 meters, 10 meters plus 10 meters. However, your displacement is the straight line distance between your starting and ending points, which can be found using the Pythagorean theorem. In this case, the displacement is about 14 meters in a northeast direction. As mentioned earlier, displacement is a vector quantity. It tells us how far out of place an object is, that is, the change in position from the start point to the end point. It requires both magnitude and direction for a complete description. For example, stating, "Your displacement is 14 meters northeast" provides a complete picture of your position change. To make the distinction between distance and displacement that much clearer, imagine you walk around the entire perimeter of the square and return to the starting point. You've covered a distance of 40 meters, but your displacement is 0. Why? Because your starting point and ending point are the same, there is no change in position. This illustrates a key point. While distance accumulates the total path traveled, displacement considers only the net change in position. You might be wondering, how do these concepts help us in everyday life? The equations and principles of motion help engineers to construct cars, planes, and trains that can travel safely and efficiently from one place to another. Understanding the motion of vehicles also helps in designing better traffic management systems. Understanding motion will also help us to grasp further concepts in the forces unit, like momentum, kinetic energy, and potential energy. In today's lesson, we delved into the differences between distance and displacement. We learned that distance is a scalar quantity representing the total path length traveled by an object, measured solely by its magnitude without concern for direction. Displacement, on the other hand, is a vector quantity that considers both magnitude and direction. It measures the shortest distance from the starting point to the ending point. We also highlighted the importance of these concepts in various real-world applications and how describing motion is a cornerstone of topics in physics. In our subsequent lessons, we'll expand on this by considering speed. Watch the rest of the GCSE physics course at Sophos Education.